All right, guys, we are going to be looking at some AP examples of that like candidates test and how do we do this if we're looking at things like closed interval, open interval, calc OK, all the things. These are all from AP Classroom, so they're all going to be like pretty great rigorous problems to go over. So let's look at this very first one. It says that calc is okay. So it also says let f be the function given by blah, blah, blah. Find the absolute minimum value of f and then show the analysis that leads to that. So the very first thing I know is that like I know a minimum occurs for function f when f prime, right? Like think a minimum. So f prime is going to change from negative to positive, right? Because that slope's going to go from decreasing to increasing, and that's what's going to create that like minimum value. So let's go over here and like take a look at like where do we actually find that minimum value occurring? So f prime of x, we also know that, remember, when that minimum occurs, that slope is 0 at that point. So we're going to say like, where do we find the slope equals 0? So let's take the derivative of this function, and I get 12x cubed plus 3x squared minus 42x. Let's take a GCF out. Let's take a 3x out, and then we're left with 4x squared plus x minus 14. I'm going to factor this guy right here. 4 times 14 is negative 56. So factors of negative 56 that add up to 1, that's going to be 8 and negative 7. And then I always put them over that a value to turn them into factors. So we have 4x plus 8, which simplifies down to 2x. Whoops, x plus 2. Went a little bit fast there. And then we have that 4x minus 7. Double check, make sure you're good to go with these guys. This means that these three solutions, so f prime of x equals 0 at x equals 0, 7/4, and negative 2. So these are all going to be like my critical points, right? Or like what I'm checking. I can also kind of like narrow it down a little bit in a way if I'm like, okay, I know that these points are going to be negative 2, 0, 7/4. And I know that if this has a degree of 3, if we're like, okay, what's going on with a degree of 3? That in behavior and a degree of 3 is like down up. So I know that all these multiplicities are 1. So I know that this would be moving something like this, right? So we're negative, we're positive, we're negative, we're positive, which means decreasing, increasing, decreasing, increasing. So we can really rule out 0 as being like a potential suspect, because if we want a minimum value, that's going to be where my derivative changes from negative to positive. So we really only need to look at negative 2 and 7/4. Because I'm saying that 0 is going to be a relative maximum, not absolute, right? Because x to the 4th has up, up in behavior. So when I check that, I'm going to substitute negative 2 into my original f of x. So we're saying like 3 times that negative 2 plus negative 2 cubed, or negative 2 to the 4th, sorry, minus 21 times negative 2 squared. And calculator is okay, so I would just plug all that in my calculator. And when I do, I get negative 44. And when I plug in 7/4, I get negative 30.816. Because I'm looking for absolute minimum, that looks like right here, that's going to be occurring at that negative 2. So I'm going to come over here to the side and give my summary statement. I'm going to say f of x has an absolute min of negative 44 at x equals 2. And remember, if we wanted to check that as well, like we have our candidates, so you could pull up that calculator and I could just go in here and say, okay, I know I want 3x to the 4th. It's always nice to like kind of figure out these little calculator cheats. So x cubed minus 21x squared. And what we can do is we can come in here to this graph. Let's do a little zoom 6. And I can go over here to the second trace, so that calc menu, and I can find a value. So I can say, okay, when x is -2, what is y? And that gives me that value really fast, and like just an added bonus of being able to use their calculator. 7/4. It just keeps those order of operations like nice and clean, so I can do that really quickly and easily. And then just check, let's just check 0 because like it takes 2 seconds. So when I check 0, I notice that that's 0. So, and also when I see that graph, that's that relative maximum right there. Next question says, what is the absolute, so we're looking for the absolute maximum of this function. So very similar, my first step is I'm like, okay, I know that the maximum is when f prime of x goes from positive to negative, right? Because we went from increasing to decreasing. That's like the definition of a maximum. And let's get this done. So f prime of x equals, take that derivative. We have x squared minus 8x plus 12. Oh, nice and easy factor. Love this. X minus 2, x minus 6. So I'm checking. I know that f prime of x equals 0 at -2 and, oops, +2, +6. All right. Remember from last night, if you were on a closed interval, you also have to check those endpoints. So we have our x's and our f of x. I'm going to be checking 0 for sure. I'm going to be checking 9 for sure. And then I have two potentials, which are going to be 2 and 6. I can also narrow some down because this is not calculator, so I might not want to substitute all these values in. It might take a while. If I look at this guy, I can notice that when I have this guy right here, let's look at this. We have a 2 and a 6. Then this is a parabola, right? X squared, so we're going to be above, below, above, which means that we're going from increasing, decreasing, increasing. This automatically is going to get rid of that 6, so I don't even have to worry about checking that 6 out because I know that 6 is going to occur at a minimum. So let's get this done. I also know that I can like get rid of 0 because it's increasing from 0 all the way to 2. So if we're increasing all the way to 2, it's like not going to be my highest value. So plugging in, 2 cubed is 8, so we have 8/3. Let's do f of 2. And really, you just have to get an idea of like what that value is. So minus 4 times 4 plus 24 minus 5, right? So we have 8/3 minus 16, or minus 21, plus 24. So I can kind of like get a little bit of a guess that this is going to be somewhere around 5, right? Somewhere in that neighborhood. Let's see if we need to be more specific after substituting for 9. So let's try f of 9 because this doesn't ask me to do any of the values. 1/3 times 9 cubed, well that's going to be a big number, minus 4 times 81, also a big number. 12 times 9 minus 5. And then we keep on working through this, right? 243 minus 324 plus 108 minus 5. So let's add these guys together, all of our positives. It's already looking pretty promising, I'm not going to lie, but we can keep on going and like get this finished just so we know for sure. So adding together that 243 plus that 108, we have 351 minus 329, right, when we combine these guys right here. So I already see that that's going to be a bigger value than 5. That's probably going to be somewhere around, well, it's 22. I was going to like make it approximate. So we know that this guy right here is 22. Because that is my largest value, I know that this is going to be my maximum over the interval. So again, remember we're checking those critical points, and when we have like a closed domain, we also have to check those endpoints of the domain. Looking at this graph right here, we have this function and it's a piecewise function. So we have a semicircle, right? And then we have this e to the negative x minus, or to the negative x over 3. And this is the derivatives, right? So this is showing us what the slopes are. And remember, if we're being shown what the slopes are, then this right here, we're looking for where does the sign change. So it says right here, find the value of x which f of x has an absolute maximum. Again, we know that that happens when f prime of x changes from positive to negative, right? And just to like note that again, if we have positive slope, then we have negative slope, then a maximum is going to be occurring right around there where that slope is 0. So f prime, it looks like we have some intervals. So f prime of x equals 0 at -2 and 3 natural log of 5/3. So let's get that kind of like put down here and look at this line. So we have our critical values, right? We have -4 because that's the endpoint, +4, that's the other endpoint. I know that I have a critical value at -2. I know that I have a critical value at, let's see, 3 natural log of 5/3. What's going on here? Let's check this out. We have all positive slopes. So since it's positive and positive, all the way to that 3 natural log of 5/3, let's get this guy highlighted. It is going to be, my function is increasing because the derivative is positive. So, right, we have f prime of x is positive, then f prime of x is negative, so it goes to decreasing. Because this function keeps on increasing, I don't know what the values are, but I do know that the function keeps on increasing until we get to that 3 natural log of 5/3. I know that that is going to be my absolute maximum. So I'm going to say that f of x has an absolute max at x equals 3 natural log of 5/3 because f of x, f prime of x is positive from 0 to 3 natural log of 5/3 and negative from, or I'll do little parentheses here, 3 natural log of 5/3 to 4. So we're saying here, and then we'll also say, and f prime of 3 natural log of 5/3 equals 0. So what we're saying here is that the derivative is 0 at that point, and then before that point we are positive, or we're increasing, and then we're negative, so that function is decreasing. We can even give a summary, like what this means right here is that since it's positive, f of x increases, and negative, f of x decreases. So there is like my definition of a maximum, right? We are going all the way up, 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 and then we start decreasing from that value, which means that that 3 natural log of 5/3 will be the maximum on that interval. Last guy, we have this table here, and I'm going to also do this kind of like a number line going on because this feels pretty overwhelming to look at. We haven't talked about the double derivative yet. We will be talking about that later on, so know that like that is to come. But it looks like we're having some key things going on here at 0, 1, 2, and then 3. Sorry, this should be a 0. So let's get an idea of what's going on. It says we're looking for minimums or maximums on this interval from 0 to 3. So if I look at what's going on here with the derivative, we are negative from 0 to 1. We are negative from 1 to 2. Let's do f prime of x. And then we are positive from 2 to 3. If this is what's happening to f prime of x, this means that f of x is decreasing, decreasing, and then increasing. I also have some values here that I can kind of go along and say. I know that f of 0 is 1. So if you were to think about this graph, right, f of 0 is 1. F of 1 is 0. F of 2 is negative 1. And what's going on here is that we are decreasing, decreasing, and then increasing from there. But I still know that f of x is negative between 2 and negative 3. So it's still going to be below the x-axis until it gets to that positive 3. So let's get an idea. So 1, 2, 3. Let's get a good idea of what's happening here. We're looking like on the interval from 0 to 3, we have a minimum at 2 and our maximum is going to occur at 0. So I'm going to come here over 0 to 3. F of x has a max at x equals 0 of f of x equals 1 because f prime of x is negative from 0 to 2, so f of x decreases. And then we can say over 0 to 3, f of x has a min, absolute min, at x equals 2. F prime of x equals 0, f prime of 2, and f prime of x changes from negative to positive, meaning f of x goes from decreasing to increasing at x equals 2. So some sort of summary along that line, and then you are good to go. If you are looking for these answers again, they are all in your OneNote under that key page. Also, there is some pretty good practice for you guys in Delta Math if you are looking to get a little bit more of this in.